double integrals over general regions. For the following integral, reverse the order of integration and evaluate the integral. The integral as written tells us to integrate with respect to x and then integrate with respect to y. But we want to integrate with respect to y first, and then integrate with respect to x. What are the new bounds? That's the first thing that we need to tackle. The answer lies in looking at the original form of the integral. Let's find the region of integration. Notice that x runs between y and 8, and y runs between 0 and 8. And so, for a fixed value of y, x will run between y and 8. Let's look at that graphically. For a fixed value of y, x will run between y and 8. And so my region of integration is this triangle below the line y equals x and running between x being 0 and 8. What if instead we fix x first? So if we're fixing x first, that means that we're first integrating along to with respect to y, which is what we want. If we fix x, then y will run between 0 and a height of x. So y will start down at the x-axis and go all the way up to the line y equals x. And so my region of integration, or my new bounds, however you want to put it, is x will go between 0 and 8, and then for each value of x, y will run between 0 and x. So let's put this information into our bounds. I'm integrating with respect to y first, and y runs between 0 and x. Then I integrate with respect to x, and x runs between 0 and 8. And so here's my integral. I've now put the function in that we were given. We want to integrate with respect to y. And so I think what I'm going to do is just look at this one piece. Keep in mind that if you're integrating with respect to y, then x is a constant value. So think of x as your favorite number, like maybe 10. So if x was, I guess it can't be 10 because we're going between 0 and 8. Let's make x 5. So if x is, say, 5, for example, then x squared would be 25, and e to the xy would be e to the 5y. So just think of x as a number. It'll be easier when you integrate. And so let's do an indefinite integral for this. We need to find the antiderivative. And what I'm going to do is I'm going to set u equal to the exponent xy. So u is equal to xy. And then in that case, du is x times dy. Now, like I said, keep in mind that x is a constant value. So it's not a variable, it's a number, like 5. So what I'm going to do is I'm going to break x squared up into x times x, and then I'm just going to bring one of the x's over near the dy. And when I do that, notice that I have x dy now. That's going to be my du. And then I have e to the xy. That's going to be e to the u. So let's go ahead and do our substitution. And I have an x left over, and that's okay because x is not a variable, it's a number. Again, think of x as being, for example, 5. So if x is just a number, then it's just a coefficient. Let's integrate. We're integrating with respect to u, keeping x constant. And when I do that, I get x times e to the u. Now substitute back. Remember, u is equal to xy. And so the antiderivative is x, e to the xy. So let's put that in our definite integral, and we evaluate at y equals x, and then subtract the evaluation at y equals 0. So y is running from 0 to x, evaluated at x, evaluated at 0, find the difference. Now keep in mind x is just a number. All right, so do the evaluation, and this is what I get. Now, e to the 0 power, that's equal to 1. And so when the dust settles, I get x times e to the x squared minus x. I'm going to put this information into my double integral. So remember, I had a double integral, and I instead of the inmost integral, I just put in x times e to the x squared minus x. So my job now is to just integrate with respect to x. My first integral, you might have to do that off to the side, but the first integral is not that hard. You might have to do another substitution, have u be x squared, then du would be 2x dx, and so on like that. Then the second part of this, minus x, that's pretty easy for you by now to integrate. So you go ahead and integrate and then evaluate. And it's really easy to get confused here, but keep in mind that e to the 0 is 1. A lot of times in the middle of a problem we forget that. So we have minus 1/2 64, but then we have minus 1/2 times 1. And so altogether I have minus 65 halves. And then I have the e to the 64 over 2. And so we have successfully reversed the order of integration and evaluated the integral. You take care and have a great day.